Hello friends and my dear students. Welcome to session 10 on projection of plane surfaces demo, that is circular lamina. This circular lamina we are doing using solid edge. Now we already started in session 9 and we'll continue this projection in this session 10 also. See here, up till here, we are done in the last session. That means a circular lamina of diameter 125, that is 62.5 is the diameter, given one decimal place. That is why 62 to 62.5 has been made. You can change it in format style. You see here format style. In this, under units, no, I made it round off to earlier 1 it was, now 0.1. That is why it got changed to, okay, it got changed to 62.5. Okay, actually 62.5 is the diameter. Actually 1:2 scale, no? That is 125 is the diameter and 62.5 are taken. A, B, C, D, E, F, G, H are named. I imagined 8 edges or 8 corners, but these are all called points. A, B, C, D, E, F, G, H and all that, they are called points. And imaginary corners you can call it. Okay. Now, even if you lift E up, it will be resting on point A and HP. Even if you lift A up, it will be A up, it will be resting on E and HP. That means any one of them you do. They have said a circular lamina has a point of its rim or circumference on HP, that is A, okay, or E, whatever you do. Now I have made A and HP such that surface is inclined at 60 degrees to HP. Can you follow? Surface is inclined at 60 degrees to HP, or since AE diameter is parallel to XY line, since we are moving it parallel to AP, this you can even call diameter containing the point, that is AE. Diameter containing the point on HP, that is AE, is inclined at 60 degrees to HP or surface inclined at 60 degrees to HP. Both are same. In that way, you have completed this. Now we will take the projections here. Now, as you see here, you take line and take 0.13. Okay. This here afterwards, this is a good tricky problem in the sense you keep enlarging it and all that, so that it will be better for you to do. It will be easy for you to do comparatively. Okay, you take this. Now you from this D dash F dash also take the projector down. From E dash also you take the projector down. Okay, then from G take a projector. From F and H will be on the same point. From F take a projector. From E also take a projector. From D also you take a projector. From C also take a projector. Okay, now as you see here, I have taken the projectors from all these points. You can give this leader also how you have done it and all that. Okay, now you see carefully here. You have so many points here, and this is point A, this is point B, this is C, D, E, F, G, H and all that. Okay, now unless you zoom it, you won't get the correct point. That is why you have to be careful here. Keep zooming it. Okay, keep zooming it here. In now you see here, I'll have the point here and I'll make it 0.2 only, so that easily it can be seen. This is A, B, this extra points and all that you can remove it off. Okay, now point 2 only. You have endpoint sensing is easy. See, now you have to wait for this intersection, or approximately you have this. Okay, then this point, you got intersection. If you get intersection, it will be very good. Okay, now you are getting intersection, very good. Now again in this, try for intersection, otherwise you have to zoom it. Zoom the area. Okay, and in that way you do. Okay, now once you do this, let us say I'll fit this area. Now zoom only the required thing. Full of zooming what you have to do. Okay, now you see here, now these are all the things, and if you name the corners and all that, text, it is A, B, C, D, E, F, G, H. In that way, if you do, okay, A will be here, correct now? A will be this, okay, and as you know, this will be B. I think this will be B. Okay, these things you have to do it carefully because it's a very fine and very intelligent, very interesting problem. Unless you have patience, you can't complete. Okay, this C is this, D I think is this. Okay, then E is this. Correct now? E is this. Then F is this. Then G is this. G is this. Then H is this. Okay, H is this. In that way, do. Now you have to, now when this circular lamina has a point of its rim or circumference on HP, with surface or diameter inclined at 60 degrees to HP. When you look from the top, this circular lamina will look like an ellipse in the top view. Okay, you should remember this here, it was completely lying on HP, that's why it was looking like a perfect circle only. Now it is tilted. When it is tilted, you observe the front view and top view. It is tilted to 60 degree. When you are looking from the top, it should appear as an ellipse. Okay, for ellipse also, you have an ellipse here by 3 points. Okay, now click for the first end point of the primary axis. You click here. Click for the second end point of the primary axis. Okay, then click for the end point here. In that way, you directly get the ellipse. Okay, now what you do, no, this thickness has become more, you change it to 0.5, then it will be okay. Now, directly you have got this. Now the cosmetics part, okay, be careful. This I'll take one more session to complete. It cannot be completed. But anyway, it's a good problem for you to experience the difficulty. See here, now the problem says, okay, the problem says 60 degrees to HP is over. The top view of the diameter containing the point on HP is inclined at 45 degrees to VP. The top view of the diameter containing the point. That means it is AE. The top view of the diameter containing the point on HP is AE. If I say other diameter inclined at 45 degrees to VP, or I might CG inclined at 45 degrees to VP or whatever is that. Okay. Now they have said clearly this is inclined. AE is inclined at 45 degrees to VP. Okay. That is top view of the diameter containing the point on HP is inclined at 45 degrees to VP. Take carefully because they should go along with the curve. you should always try for intersection and all that. Keep zooming and carefully you do so that the error is minimized. Okay. Now you see here. Now once you copy and paste, okay, you want H point, F point, B point, C point, and all that. That is why you have to split. I want this with the grid. I want A point, B point, C point, D point, E point, F point, G point, and all that. These things I need it. Otherwise, I can't complete the problem. Okay, this is B. Okay, these things I needed unless I have this. Okay, I'll just zoom the area you see here. I'll zoom it. This is H, no? This is F. This is A. This is B. Okay. Now you see here, I'll do the ellipse. Ellipse. First point you take here. Second point you take here. Then you take such that okay, now it's okay. More or less it has covered. Now you see here, once you've done this, this is more or less passing through all the points. Earlier, some small mistake was there because we had not sensed this point. Now everything is sensed properly. It is. Now you see here, now this second stage top view, when the surface is inclined at, okay, this 60 degrees to HP, okay, keeping constant, if you move with respect to A, the top view won't change. That means second stage top view and third stage top view should be same. But as you see here, unless you see here, this, you have to split it because I want all the points here. Now what I'll do, I'll take this, I'll cut this so that I want the grid also. I'll take this and cut here. I'll take this and cut here. And I'll take this and cut here. I'll take this and end of point I'll cut here. So that you see here this is all is cut at these places using split command. In the same way, using split command, you take this and cut at this place. Take this point, cut at this. Take this point, cut at this. Take this point and cut at this. Take this point, take this line and cut at this. Okay, now once you do this, okay, as you are aware, okay, now if you move this down, if you move this, you can move with the grid. Okay, can you follow? This, if you do, you can move with the grid. This is what actually, now what you have to do is, you have to rotate in such a way that AE is inclined at whatever is that 45 degrees to VP, that you have to do it inclined at 45 degrees to VP, and you have to get the final stage front view. This again you have to do it carefully. Okay, I just showed it. Now I have done it. The next what you have to do is keeping this inclination constant. That is why this top view and this top view is same. You have to make AE inclined at 45 degrees to VP and get the corresponding front view. Okay, this is a very good problem. Okay, thank you very much for watching. We have come to the end of session 10. We'll continue in session 11. We'll continue this problem in session 11.